Hello everyone, welcome back. This is Ahmed for Eduonix, and this is Understanding Chef, the configuration management tool. And this is the second section of your course, where we are going to start exploring tools of the trade. We are going to have a look at the Chef development kit. We're going to know in a moment what this means. And also, we are going to have a brief introduction to the Ruby programming language, the programming language that is used to write Chef recipes. So let's get started. Now, the first thing we're going to use, the first tool of the trade, if you wish to call it, is Vagrant. We have briefly discussed Vagrant in the last section, and we have discussed the concept of infrastructure as code, or IAC, and we said that this concept is starting to trend together with other concepts like cloud computing and DevOps, and how everything now is running on the cloud. Vagrant is one of those tools that let you run your infrastructure as code. Vagrant is a tool that let you download and launch virtual machines from templates. Those templates are available on the Vagrant website, and it's also available on other sources like GitHub, for example. Some people make custom templates, and a template basically means an operating system that is pre-installed. Let's say, for example, that I want a virtual machine that has Ubuntu 15, version 15 installed, and I also need to have Apache to install and PHP. These are my requirements, for example, to build a web application. So instead of launching a virtual machine on VMware or VirtualBox and start installing the operating system from scratch and then start installing Apache, configuring it and installing PHP, configuring it and so on and so forth, Vagrant has cut it short. Vagrant has provided an easy solution for you. You can just point to a box that contains your components, a box that contains Ubuntu, possibly with Apache and PHP, download it, launch it, and in a matter of minutes, you're going to find a machine that is running with an OS pre-installed, with Apache installed and PHP, and you can just start writing code. You can just start building your application. So imagine how this saves time and effort, and this also is part of what we call IAC, or infrastructure as code, because as we're going to see in a moment, you are going to edit a file that is called Vagrant file, and this file specifies how the machine should behave, how the machine should communicate on the network, what are the characteristics of the machine in terms of memory, CPU, and so on and so forth, in addition to many other things. You can even configure software to get automatically installed on the machine when it gets started. So Vagrant is our choice. We are going to use it in this class because it is very easy and it will quickly give you a machine ready for work. And Vagrant can be installed on all major operating systems. It can be installed on Windows, Linux, and the Mac. The only prerequisite for Vagrant to be installed is to have a virtualization platform pre-installed. By default, we're going to use VirtualBox, but you are not bound to this specific virtualization platform. You can use also VMware or any other virtualization platform that is supported by Vagrant. So if you don't know about VirtualBox, it is very easy to install. It is a virtualization platform. Just head to your browser, and I'm just going to write download VirtualBox. It will give you this page, Oracle VM VirtualBox. This is the software, and as you can see here, it is supported on multiple operating systems. You can just download your version, okay, and install it. It is very easy to install, and once you're done, you're going to have VirtualBox on your system. It looks like this. This is the VirtualBox, and these are virtual machines that are installed on my system. As you can see here, I have a Windows, I have a Red Hat base system, or this is actually a CentOS system. So as you can see here, I'm running a Mac, but I can run Windows, I can run CentOS or Red Hat Enterprise Linux. I can run multiple operating systems on my same machine. So this is amazing, but you're gonna also need to download Vagrant after you download and install VirtualBox. So let's go ahead and type download Vagrant on Google, and as you can see here, you are directed to this page, vagrantup.com/downloads.html, and Vagrant as VirtualBox is supported on all major operating systems: Windows, Debian Linux, Red Hat-based Linux or CentOS, and of course the Mac. So you're gonna download and install Vagrant. It's very easy to install. It's nothing complicated. And once you are done, all you have to do is just make a new directory, call it whatever you want. In my case, I've called it CentOS 7.3 because this is the version of the operating system that I'm going to download and use using Vagrant. I'm going to use CentOS 7.3 for this class. So just create a directory on your home directory or whatever path you wish or you desire on your system. And inside this directory, just cd to this directory. And inside this directory, you are going just to run the following commands. So the first thing we're going to do is that we are going to issue vagrant box add, and vagrant box is a command used by vagrant to add the box into your repository or into your local machine. So this is just going to download the box and add it to your local machine in case you need to launch multiple machines based on this box, because a single box can be used to launch more than one virtual machine using vagrant. So this command, vagrant box add, and then you give it the name of the box, Bento CentOS 7.3 or 7.3. And you may be wondering, where did this come from, Bento/CentOS 7.3? Well, by default, Vagrant Box is going to search the website of Vagrant. It is programmed to do this. It will go and search for a box on the Vagrant website that is called Bento, or under the project that is called Bento, and the box itself is called CentOS 7.3. It is just going to go and grab this box from the internet. I have already did that. And then you are going to type vagrant init and then give it again the name of the box, which is Bento CentOS 7.3. And vagrant init here is used to create the vagrant file for you. Remember when we said that the vagrant file is where you write the code that defines how the virtual machine will behave or what the characteristics it is going to have? Well, this command, vagrant init, is what creates this file inside your directory, inside CentOS 7.3. So I have already ran this command and it created this file for me, vagrant file. As you can see here, it's a long file, but it is not hard to understand. It is very well commented. And by the way, it is written in Ruby as well. So as you can see here, Ruby is used extensively in DevOps and IAC. So as you can see here, Ruby is used extensively in this class. Okay, so as you can see here, it just contains some of the characteristics of the machine. Here is the memory. Memory is 1 GB, so on and so forth. Okay, let's exit that. And once you have the vagrant init and the box in place, you can just start the machine by using the vagrant up command, optionally adding -- provider equals provider virtualbox, which is just informing vagrant that you are going to use VirtualBox as your provider. If you are using other providers like VMware, for example, you will have to specify that provider when you run vagrant up. I'm gonna press enter because I have destroyed this machine. I'm gonna press enter, and as you can see here, it is importing the machine from the box. And once it is done, it is going to launch it. And once it is launched, you can just issue vagrant SSH, and vagrant SSH will automatically log you inside the machine with the default user vagrant. It uses the public-private key technology to log into the machine rather than using a username and a password. It just uses the private key to log into the machine. And actually, this is the most commonly used method of logging to cloud machines. Like, for example, if you've used Amazon AWS or Google Cloud or Google Compute or Microsoft Azure, you're going to see that they use public-private key method for logging users rather than giving out passwords. Anyway, let's clear the screen, and now we are inside the vagrant machine. Now, in the coming lecture, we are going to start exploring Chef. We're going to start downloading and installing the Chef development kit. We're going to know what Chef development kit is, so see you next. Hello everyone, this is Ahmed for Eduonix, and this is Understanding Chef class. In this section, we are discussing the tools of the trade. We have discussed in the previous lecture Vagrant and how to download and install Vagrant, how to launch a machine using Vagrant. We have already did that at the end of last lecture. Now let's shift our attention to Chef itself, and let's see how Chef works in the most basic way, in the most abstract manner, or without delving into any of the details, because the details are what we are going to deal with in the rest of this class. Let's see at a general level how Chef works. Chef, as mentioned, is a tool that helps you ensure that a particular server or a number of servers is at a specific state. It ensures that this server is configured this way, has this number of packages installed, have this number of users and groups created, and so on. To instruct Chef of this desired state, you use something called a recipe. A recipe in Chef terminology is just a text file written in the Ruby programming language. It contains one or more instructions that are understood by Chef. Chef executes those instructions one by one, top to bottom. You can always put all your instructions in a single recipe and let Chef execute it for you. Chef will not complain, it will just execute the recipe for you and nothing was gonna happen. But actually, this is not the best practice. This is not how Chef is designed, and this is not how you should use Chef. Why? Because this will make your code cumbersome and hard to maintain. Additionally, you cannot reuse your code in other places, like for example on other nodes. And in order to better understand this point, because it's very important, let's have an example. Let's say that you want to install a number of content management systems. If you haven't heard that term before, a content management system is just a software that lets you install or launch a web application that is ready-made, and you just go and point and click on this application, customize it in order to create whatever website you want. A very prominent example of this is WordPress, Joomla, Drupal, and other content management systems. You just have a ready-made website that just needs to be customized, and you can just start writing articles and pages and customize them on the website, add graphics and add colors and themes and so on and so forth. So let's say that you want to install a couple of those content management systems. Let's say you decided to install WordPress and Joomla, both of which are types of content management systems, and both of them require the PHP language to be installed on the system. So you can create a separate recipe for installing and configuring PHP. Then you can write another recipe for WordPress and a third for Joomla. Notice here that because I have written a specific recipe for installing PHP, this recipe can be reusable. This recipe can be shared among WordPress and Joomla. This is different than if I wrote a long recipe installing PHP, then installing WordPress, then another recipe for installing PHP again and installing Joomla. Now, if you want to change something in the PHP version, for example, or you want to make some important changes to the php.ini configuration file, you are going to have to make this in the WordPress and in Joomla recipes and in any other recipe where PHP has to be installed. So a much better approach for this is to have a separate recipe for PHP, where the packages are being downloaded and installed, and any configuration that is specific to PHP needs to be done in that recipe and not in other recipes that are not related to PHP. So this is how you make your code modular. This is how you can avoid errors as much as possible, and this is how you can reuse code, because this is the point of infrastructure as code. You use all the tips and tricks that programmers use in order to build an infrastructure. So back to our example, you have created a PHP recipe, you have created a WordPress recipe and a Joomla recipe. Now you want to combine the PHP recipe with the WordPress recipe in order to start creating a WordPress application. You need to execute those recipes in turn. So you want to group those recipes in some group or some unit or some box, if you wish to call it. But Chef has another name for this. It calls it a cookbook. You see the metaphor, because it's Chef, so you have recipes containing instructions for making food, for example. But in our case, of course, it's not food. It's building infrastructure and configuring servers. So when you have multiple recipes, you usually put them in a cookbook. So this is how Chef refers to its instructions, refers to its group of recipes. It calls it a cookbook. So you can have a cookbook for WordPress. This cookbook includes a recipe for installing the package itself, for installing WordPress, and another recipe for installing PHP. And you can have another cookbook for Joomla. You can have a third cookbook for Drupal. You can have a fourth Drupal, and so on and so forth. To do its job, Chef uses a number of components. We're going to study those components in detail throughout this class. But in general, it uses three components. A Chef client. This is a set of tools that allow Chef to execute cookbooks and recipes either locally or by contacting a central Chef server. We have talked about Chef client in the previous section briefly. We said that Chef is very flexible, that it lets you run your recipes either on just one node, one server, or on as much as thousands of servers by using a central management server or a central Chef server. So in this environment, you have a Chef client. Chef client is responsible for executing the recipes either locally or by pulling those recipes and pulling those cookbooks from a central server and executing them locally on the node. The other component that we have is the Chef server. The Chef server is a software that is used to deploy a Chef server. A Chef server, as we said, is the central management system or the central management node which distributes recipes and cookbooks to all the nodes that are subscribed to it, all the nodes that are connected to it, all the nodes that are configured to pull the recipes and cookbooks from this server. Several cookbooks for several organizations can be placed on this server, and clients would pull cookbooks from this server for execution on a periodic way, perhaps using a cron job, for example, or a scheduled job. And finally, we have Chef DK. And Chef DK is short for Chef Development Kit. It contains all the Chef client tools in addition to other development and testing tools that can be used to write and test cookbooks before deploying them. So Chef DK contains Chef client plus other goodies, plus other bonus tools or other value-added tools. Those tools help you test your recipes, helps you do a lot of work on those recipes to ensure that they are what you desire, that they are going to work the way they are expected to, and then after testing and after ensuring and confirming that those are the recipes that you want to deploy, you can start deploying them to the Chef server or deploying them directly to the node if you want to run Chef client locally. So this is basically how Chef workflow is designed. This is briefly how Chef works. Now let's start our lab. In this lecture, we are going to install Chef DK on the Vagrant machine that we have just created in the previous lecture. So here we are on our Vagrant machine, and we are going to use the RPM command. RPM is the package manager, or not a package manager, it is the command that is used to install packages on the CentOS or Red Hat based hosts. It's called RPM, and the corresponding command on Ubuntu is called dpkg. If you are working with Ubuntu, you may have stumbled upon this command lots of times. So we are going to use RPM, and of course we're going to precede it with sudo because we have to run this command as root. So we are going to run sudo RPM and give it these options -ivh in order to install the Chef DK package, and we're going to pass in the URL from which we can download the Chef DK, okay, and the version of Chef DK that is currently available on the website at the time of this recording is 1.3.43. Gonna leave it for a few moments to download and install this package. Now once installed, you will need to verify this installation. You will need to make sure that you have correctly installed Chef and that you are able to run Chef commands from your command line. In order to do that, we are going to run chef-v or -v and press enter, and you should see this output. Chef Development Kit version 1.3.43 and Chef Client version. As you can see here, we have the Development Kit and the Client. Client is a subset of the DK or Development Kit. The Client version is 12.19.36, and we also have some other tools. That is the Workshelf. We're going to talk about it later in this class. The version is 5.6.4, and also the Kitchen version 1.16. Congratulations, you have successfully installed Chef DK on your machine. Now, the rest of this lecture is going to be dedicated to talking about Ruby. If you are a Ruby developer or if you know Ruby, you can just skip this section and start section 3, where we're gonna start writing Chef recipes. But if you are new to Ruby or if you haven't done much programming before, I encourage you to watch carefully this part of the section and try all the examples that I'm gonna present. Because Ruby, as we said, is the language that is used by Chef. And although you don't have to be a Ruby developer in order to write Chef recipes, in fact, most of Chef users are not Ruby developers at all, but a little knowledge of Ruby will help you a lot when you write recipes and will help you write code that executes your desired tasks. So this is going to be the topic of our next lecture, and see you next. Hello everyone, welcome back. This is Ahmad for Eduonix, and this is Understanding Chef course. In this section, we are discussing tools of the trade. In the previous lecture, we have seen how we can install the Chef DK, our primary tool that is going to be used extensively throughout this class. We are going to use it to write recipes and play with them and see their effects. And as we said, Chef DK also includes the Chef client. It's pre-installed or bundled with the Chef DK, and it also includes some other tools like the Workshelf and the Kitchen. Now, in this lecture and till the end of this section, we are going to talk about Ruby as a language. We are going just to scratch the surface. We're not gonna teach you all the Ruby language specification and commands, but I'm gonna give you what you are going to use with your chef recipes. If you are a Ruby developer, or if you understand Ruby, you don't have to watch this lecture. You don't have to watch the rest of this section. You can just skip to section 3. If you don't, I advise you to watch carefully this part of the section. So, what is and why Ruby? Ruby is a modern scripting language created in 1993, which makes it newer than other scripting programming languages, relatively newer. It was created by a Japanese developer, and it was intended to replace the old Perl programming language. Ruby gained massive popularity in the early 2000s, when the documentation was finally translated from Japanese to English, and also when the infamous Ruby on Rails web development framework was introduced. I bet you have heard this term before, Ruby on Rails, if you are anywhere near web development, and if you have used any of the web programming frameworks like CodeIgniter or Laravel, or any of the web frameworks that use PHP, you're gonna hear this term, Ruby on Rails, more often than not, because it is such an amazing web programming framework that other frameworks are borrowing features from it and are incorporating those features in their own frameworks. So, because of the translation of the Ruby documentation from Japanese to English, and because of the introduction of Ruby on Rails, Ruby became a very, very popular scripting language that can be used in lots of things. It's not just limited to web programming, as we're gonna see. It is used as a general purpose programming language, and in our case here, it is a domain-specific language. It is used by chef in order to write instructions in recipes and executing them on the system. Ruby can be used as an object-oriented programming language as well as a procedural and functional one. So you see that it is very flexible. If you want to use it as a procedural one, if you don't like object-oriented programming, or if your task does not require object-oriented programming, does not require classes and objects and those things, you can just use it as a procedural or a functional programming language. Ruby is used by configuration management tools like Chef and Puppet. It is also used in Vagrant, as you have seen in the previous lecture. As you have seen in a previous lecture, when we had a look at the Vagrant file, the language that this Vagrant file is written in is Ruby. Ruby gets installed automatically when you install chef.dk. To test that yourself, you're gonna run chef exec ruby-v. And this is a very important note, and this is a very important point to notice. Now, when you install chef.dk, Ruby gets installed automatically with the package. But this does not mean that Ruby as a language is installed. So if you run Ruby on the terminal like this, you're gonna see that command is not found because Ruby is not installed on this Vagrant machine. But it is installed as part of chef.dk. This means that if you have Ruby already installed, it will not interfere with the Ruby version that gets installed with chef.dk. In other words, you can have two versions of Ruby, one for your own programming or for your own tasks, and the other one is specific to chef. It is gonna only be used by chef. It's not gonna interfere with any of your scripts that are already written in the version of Ruby that you have installed on your system. So if you want to have a look at the version of Ruby that gets installed with chef, you're gonna write chef exec Ruby. And once you write chef exec Ruby, you are actually running the Ruby interpreter that comes pre-bundled with chef.dk. So let's run chef exec ruby-v. So let's run chef exec ruby-v in order to see the version. And as you can see here, I have Ruby 2.3.1p112. And this is the version of Ruby that is installed with chef. This is the version that is used to interpret the recipes and run them on the system. And again, this is totally different than any other Ruby version that is installed on this machine. So if you have another version of Ruby, you're perfectly fine. Both versions can work in parallel without interfering with one another. So, as mentioned, you don't have to be a Ruby programmer to be able to use Chef effectively. In fact, most Chef users do not know Ruby. However, some basic knowledge of the language will be a great added value. In addition, if you decided to learn the language in depth, you can unleash the full potential of the language and write more complex recipes. Let's start by the traditional Hello World example. Using your favorite editor, I'm going to use Vim. If you want to use Vim or Nano, you are totally free. Just create a text file that is called hello.rb and write the following code inside it. So I'm going to create a file that is called hello, and I'm going to give it the extension of rb. And okay, yeah, Vim is not fun. I'm going to quickly install it. And if you have worked with Linux before, and of course you did, you're gonna understand that the extension Ruby, the extension of RB, does not mean anything to the operating system. You can just name this file whatever you want with whatever extension you want, as long as you're gonna pass it to the Ruby interpreter or to the Ruby binary file. It's gonna be executed, whether it was ending in .rb or in any other extension. Linux and Unix just don't care about the extension of the file. Windows does, and you're gonna have to be very careful on Windows when you change the extension of a file. But for consistency purposes, we're gonna leave this file as hello.rb, just as not to forget that this is a Ruby file. Okay, now Vim is installed. Let's clear the screen and let's write our hello.rb. First line of code I'm gonna add is puts and then hello world. Okay, puts here is a function. If you don't know about functions, that's okay. A function is just an instruction that does a specific task. When called, in our case, puts just prints whatever is passed to it to the screen or to the terminal, and it terminates it with a new line character. So if I save this file and run chef exec ruby hello.rb, I'm gonna see that I have hello world printed to the screen, and I'm gonna have a new line after the phrase. All programming languages have some way for the developer to write comments. A comment is one or more statements that are meant to be read and understood by a human being rather than a machine. Ruby is no exception. You can write comments in any Ruby file by prefixing the comment line with the hash sign or the pound sign, if you prefer to call it. For example, let's open the hello world or the hello.rb again, and let's say that I want to add here a comment that specifies why I wrote this line of code. So let's write a pound sign or a hash and say that this line prints hello world to the screen or to the terminal. And now let's save the file and let's run again chef exec ruby hello.rb. And as you can see here, it printed again hello world. It did not complain or it did not parse the first line of the file in which we wrote our comment. That is because, as we said, comments are completely ignored by the interpreter. It just skips this line and starts executing or parsing the next line, which instructed it to print hello world to the screen plus a new line. Now let's talk about variables. A variable is a container for value. In statically typed languages like C or C# or Java, you must inform the compiler about the type of variable that you are declaring. So let's say, for example, that I have a file, let's say test.java. Don't worry, I'm not gonna use Java here in this course. This is just an example. Let's say that I want to declare a variable that is called I, and that I is an integer. I is gonna contain a number. I have to declare it that way: int I equals 1. Then a semicolon. Java and C and C# and other statically typed language obligates me to use this form. It forces me to declare the type of variable before I can assign something to this variable. After which I cannot just say, after I do that, I cannot just say I equals or is assigned to some text. If I run this code in Java, it will give me an error immediately. That is because I have defined I to be an integer at the first line of code, and then I'm assigning a string to I. I'm assigning text to a variable that is supposed to hold numbers and only numbers. Even a decimal number should not be placed in this integer. Only whole numbers, only integers. However, in loosely typed languages, and Ruby is one of them, Ruby and PHP and Python and Perl, all those are loosely typed languages, I can do that without a problem. So I can go again to hello.rb, and let's comment out this line, don't need it, and I can say I equals 1, okay, and then I can say immediately I equals or assigned to some text. And then if I puts I like this, I try to execute this code, you're gonna see that I is holding, some text is holding a string, although it was supposed to be holding an integer. And the first line, Ruby concluded that I should be holding an integer. Then when you changed the value of I to some text, it concluded that I now is a string rather than an integer. and when we passed it to the puts function, it got the latest value that has been assigned to I and just printed it to the screen. So this is one important difference between loosely typed languages and statically typed languages, which is you don't have to declare the type of variable. You don't have even a value. You don't even have a variable type in those loosely typed languages. You just specify the value that should be held by the variable, and that's it. The interpreter will carry the heavy lifting for you. It will decide the type of variable that this variable is. It will deduce that from the type of value that is stored inside this variable. Now, in the coming lecture, we're going to start talking about strings, so see you next. Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is Understanding Chef. This is the second section of this course, and we are studying the tools of the trade. In the previous lecture, we have started working with Ruby. We have started learning what Ruby is, why it is used, and we briefly discussed Ruby statements and comments and variables. Now let's have a look at strings. A string in programming languages refers to the literal text that is used in a statement. For example, let's have a look at hello.rb again. When I said I equals some text between those two quotes, or when I said puts hello world, which is this statement, the hello world, the content hello world that is between the double quotes is said to be a string. This is how programming languages refer to text. It's called a string. And strings in Ruby can be specified using two ways, either using single quotes or using double quotes. So I can just remove those, and I can change this double quotes to be single quotes, and it will work equally the same way it did work before. It will print hello world to the screen. So this informs Ruby that this is a string. Now, no matter what happens when I remove those two quotes completely from the statement, as you can see here, it is giving me an error because it doesn't know how to interpret this hello world. Is it a variable or a string, or what is it exactly? It doesn't know. So you have to put those quotes either double or single in order for Ruby to understand that this is a string. However, the type of quotes in Ruby defines whether or not string interpolation can be used. Interpolation, if you haven't heard this term before, refers to the ability to execute code inside strings. Now, let's say that I want to greet the user by the name. So let's say that I have a user and I have a variable that holds the name of this user, and let's say that this name is John. Now I have a variable. This variable is holding a value, a string value. This string value is called John. Now I want the system to greet this user by telling, instead of hello world, I want it to say hello John. And I also wanted to say hello and print out whatever content the uname had. So I can just say hello John because uname is holding the name John, but later on I want to change this variable, and when I change this variable, the value that gets printed by the puts function should change automatically. In order to do that, I want Ruby to execute code inside those double quotes. I want Ruby to examine the value that is held by the variable uname and print this value right after hello, comma, space. So in order to do that, I will have to use this form of code, a hash or pound sign followed by double curly braces like that, followed by the name of the variable, or the variable name. So it's going to be puts hello, comma, and space, then hash, an opening curly brace, the name of the variable, which is new name, then I close the curly brace and I close the double quotes. Now let's see what happens when I execute this code. As you can see here, I have hello John. What if I change this to be, for example, Ahmed? Execute it again. As you can see here, it's giving me hello Ahmed. So what Ruby did is that it read the name or the content of this variable and it printed this content inside the double quotes. Now watch what happens if I change this double quotes to be single quotes, like this. Now imagine what happened. Ruby completely ignored anything inside those single quotes. It ignored any symbols, it ignored any instructions, it just printed literally whatever was inside those single quotes. It printed the hash or the pound sign, the curly brace, the name of the variable, and the closing curly brace. it just ignored anything inside those single quotes. So this is called string interpolation. This, when it printed hello Ahmed and hello John, when I used the double quotes, this is called string interpolation. Let's write it again here. Okay, and it's gonna be used a lot in chef recipes. Lots of times you may want to print something in a configuration file, for example, and you want Chef or Ruby to print dynamic content that is going to change from one machine to another or from one condition to another. This should not be hard-coded. This should not be statically printed. This should change when some condition change. So it has to be placed in a variable, and this variable should be evaluated only when the function runs. So this is string interpolation, and it's going to be used a lot in Chef. But what if you wanted Ruby to actually print a code? We said that strings are defined by single or double quotes. But what if you wanted Ruby to print actually those codes inside to the screen? Let's say, for example, that I want to say puts or print. If I left it like that, let's just comment out those lines. If I run this code like that, it won't work. Why? Because this code, double quote, has been terminated here, and this is going to be unknown to Ruby. This is going to be, as you can see here, Vim is coloring it with green, which is different than the red color that it uses to color the string. This is not a string. This is no longer a string as far as Ruby is concerned. This is something that is undefined in the code, and it's gonna raise an error. So the solution for this is to escape the double quote that is inside my desired string to be printed. So I have to place a backslash. This is the escape character, a backslash before the double quote, the first double quote, and of course I have to do the same thing after the last double quote. As you can see here, Vim has again colored the string in red to indicate that this is again a string. It is understood by Ruby. It will be printed as it is. To prove it, let's save this file and again run chef exec ruby hello.rb. As you can see here, I am printing my name is Ahmed, and Ahmed here is in double quotes. You can also do it using single quotes, and it will do the same thing. You can use this backslash character to escape any character that is interpreted by Ruby by default. You can use it to escape this character and inform Ruby that you want to print this literal character to the screen. And some other times you may need to write line breaks to the string. A line break is what's get printed when you press the enter or the return key. So let's say that I want to have a line break between name is Ahmed and age is 37. I want this to be printed on another line. I can do this by simply entering a special character that is \n. This is a special character in Ruby. It is interpreted as a new line. Now if I save this file and I run again chef exec ruby hello.rb, I'm gonna see that name Ahmed is printed on a line and age is 37 is printed on another line. This is because Ruby has interpreted the \n as a new line character and it has printed it to the terminal or to the screen. However, in some cases, you will have more content than just a couple of lines. You may have some, for example, HTML content that needs to be written to an HTML page, and this is one of the most common examples, as we're going to see in Chef, is that you're going to use Chef to write some configuration text or configuration strings to a configuration file, and in most cases, this configuration content contains special characters, it contains line breaks, sometimes it is formatted in such a way that needs to be printed exactly in a specific way. So for this reason, Ruby provides you with something called the here docs. Imagine now that I want to write some HTML content to an HTML file. And for the purposes of this example, let's imagine that I want to print them first to the screen to ensure that they are going to be formatted the way I want them to be. So in order to do that, I'm going to use something called here docs. The here doc is just a way of formatting strings. We're going to write puts, which is the function that prints text to the terminal, and then I'm going to use those double smaller than sign. Then I'm going to follow them by a string that is not likely to occur inside the content. In other words, I'm going to put a string that is just like a key or something that is not going to be repeated in the text. I'm going to use EOT. And I'm sure that EOT, this string, is not going to be printed anywhere in the content that I am intending to print. You can just choose something that is not commonly used. Most people use EOT or EOF, which is short for end of text or end of file. Whatever string you want to use, just ensure that it does not repeat in the text itself. And I'm gonna use the following, and I'm gonna write the following HTML content. Let's say h1 hello world. This is just a heading if you are not familiar with HTML. And then I'm gonna write an h2. This is a chef course. I'm gonna close it. And once you're finished, you're gonna write this terminating string at the end of text on a line, on a single line, on a separate line with nothing, absolutely nothing before or after it. Just this line of code, just this string with a line break at the end, and it's gonna be on a single line, on a separate line, and with nothing before or after it, rather than just a new line. Now I can just save and run chef_exec_ruby hello.rb. I'm gonna see that it has printed text with the new lines, with all the characters. It has been formatted the same way I need it to be. Now, what if you want to add tabs to this text? In this case, you can just add this dash after the double small than sign, and then you can write whatever tabs or whatever indentation you need. So I can even run HTML, close it at the end, and then have a tab, character, and write body, and then close it at the end, and then I'm gonna ident those two headings like this. Okay. And because I used this dash after the double smaller than sign, if I run chef_exec again, I'm gonna see that my file has been formatted the same way I have written it in the here docs. And this is very, very useful if you want to write configuration files that is indentation sensitive. Like, for example, Python code. Python code uses indentation to define different blocks of code inside a Python file. So if you use chef to run Python, you will inevitably have to use this here docs method and use the double smaller than signs followed by a dash in order to ensure that Ruby writes the text or the code in a way that Python understands it, or in a way that preserves the indentation or tabs. And that brings us to the end of this lecture. In the coming lecture, we are going to continue working with Ruby. We're going to start by working with arrays, so see you next. Hello everyone, welcome back. This is Ahmed for Eduonix, and this is Understanding Chef course. In this section, we are discussing tools of the trade. In the first part of this section, we have discussed briefly the Chef DK or development kit, and we have installed it on a Vagrant machine. In the second part of this section, we are discussing Ruby as a programming language. We are just giving you the basics that will help you when you write chef recipes. So let's start this lecture by talking about arrays. An array in any programming language is just a way of storing multiple values in a single variable. Now let's have a look at the example in this that we have used in the previous lectures. And let's say that I have a variable here that is called systems, or system, let's just system. And let's say that this variable contains the name of a well-known system. Let's say Fedora. Fedora is a Linux flavor or a Linux distro. It's called Fedora. Now let's say that I want to store more than one value in this variable. Now instead of this variable being called system, I'm going to call it systems, and this is, of course, has nothing to do with the type of variable that I am declaring. This is just for semantic purposes. I'm going to call this variable systems, and I want to create more than one entry for this variable. So I'm going to write Fedora, Ubuntu, let's say, and Red Hat, for example. Okay. Now all those are stored in a single variable that is called systems. But if I want to work with this variable, if I want to extract, for example, Ubuntu, if I want to say the second system in the list of systems that is stored in a variable that is called system, how can I get that? Actually, it is possible, but it is very cumbersome and it requires a lot of code and it is error prone. You're going to have to break this string into tokens and extract the token that you need. And this is, of course, an inefficient way of storing multiple values in a single variable. A more efficient and a more elegant way of doing this is to store those variables in what's called an array. An array is present in all programming languages. All programming languages utilize arrays, and Ruby, of course, is no exception. In order to create an array in Ruby, you'll just have to make a modification to this code. You're going to add a square bracket at the start, and you are going to surround each value with a single quote like this, or a double quote, for, as we have just mentioned in a previous lecture, that single and double quotes when it comes to strings are both the same, except if you want to do some string interpolation, which we are not going to use here. So we're going to use a single quote, and we can use equally double quotes. It won't make any difference. So this is an array. Systems now is an array containing 3 Linux distributions, or 3 Linux flavors: Fedora, Ubuntu, and Red Hat. Now, what if I want to extract Ubuntu, which was the question that led me to use arrays? Simply, I'm gonna have the puts function, and I'm gonna call the systems array, or the systems variable, and I'm gonna open the square bracket, and I'm gonna add 1. Why 1? Why not 2? Ubuntu is the second item in the array, so why did I use 1? This is because arrays are said to be 0 based. This means that the first item in the array is having the index of 0. So the way Ruby sees this is 0, 1, and 2. So the first item in the array is having the index of 0, okay, and the last item of the array is having the value of the length of the array minus 1. So if I have here the length of the array is 3, it contains 3 items. If I want to get the last item, I will have to subtract 1 from the length of the array, or from the sum, or from the count of the amount of items in, or from the count of items in the array, to give me the index of the last item. So let's run this code and see what it brings us. As you can see here, it gives me Ubuntu. This means that I can use an array to store multiple values and extract whatever value I need from that array using the square bracket notation. This is very powerful, as we're gonna see, because arrays are used in almost all programming code. Whenever you deal with multiple values, arrays become your first option. Now, arrays in Ruby have a number of methods that can be used to manage them and to return information about them. For example, we can have puts the number of items in the systems array is, and I'm gonna use string interpolation here, as we have learned, and I'm gonna write systems followed by dot length. This is a method that is built in any array that is used in Ruby. It's called length, and it's gonna give me the count, or the number of items in the array. Let's run this code, and as you can see here, the number of items in the systems array is 3. I have 3 items. If I want to get the first item in the array, I can either add here puts systems 0 like this, which will give me the first item. Let's execute. It's giving me Fedora, which is the first item, or I can use a built-in method for this, which is called first. Array.first, I give the name of the array, then first, and running this code will give me again Fedora. Equally, I can write systems.last, and as you might expect, it will give me the last item in the array, which is Red Hat. This can also be printed using a longer method, or a longer way, which is systems.length, and I'm gonna subtract 1 from this length. Remember, the length of the array is 3, and I want to get the last item, and because this is a 0-based array, this item is having the number of 2, which is 3 minus 1. So if I run this code, okay, we have a typo here. Okay, I forgot a space here. Let's clear the screen and run the code. And as you can see here, I'm having Red Hat, which is the last item in the array. And as you can see here, what I did here is that I have placed the index of the array by calculating the length of the array and subtracting 1 from this length to give me the index of the last item in the array. And finally, I can even slice the array to get more than one value quickly without having to write multiple indices. So let's say here I have Fedora, I want to have, let's say I have also FreeBSD and Solaris, just increasing the number of items in the array. So let's say that I want to have the second item, the third and the fourth item printed. Just the second, the third, and the fourth. I can write it as follows. Systems, and open a square bracket, then put the start index, then double dot, then the last index, or the index of the last item I want printed. If I saved it and run it, I'm going to have FreeBSD and Solaris, the second, the third, and the fourth items in the array. And although arrays are very powerful, they have their shortcomings. Let's say now that I have a system or a server that is having some details or some data that I need to record. Like, for example, it has a CPU of 3 MHz, it has memory of 16 GB, it has storage or disk space of 256 GB. I want to store this in some data structure in Ruby so that I can refer to it later when I want to have or when I want to examine one of those properties of the server. If I put those in an array, I can do that. So let's say specs, and I know that I have a CPU of 3 MHz and memory of 16 GB and storage, disk storage of 256 GB, then close the square bracket. Okay, this is fine. Now, if I want to get, for example, the number of memory, the amount of RAM that is installed on the server, I can just put specs and give it the first index of the array. This confirms to the second item in the array, which is 16 GB, which is the amount of memory installed on the system. But as the number of specs increase and as the number of servers increase, this can quickly be forgotten. Now, how can another developer, for example, read my code and deduce that 16 GB, for example, is the memory and not the storage, or that 256 GB is the memory, not the storage? Or maybe if I have other specs that can hard to be deduced or hard to be figured out, like, for example, how many network cards I have. I would just write a number here that is 2, like this. So how can the developer that is reading my code know that this 2 refers to the number of network adapters or network cards that are installed on the system? Of course, this is very time-consuming operation and it is error-prone. For that reason, Ruby provides us with a data structure that is called hashes. And hashes is present in all other programming languages, or nearly all of them. Sometimes it's called a dictionary, sometimes it's called a map, sometimes it's called an associative array. In all cases, this data structure exists and it is very powerful. In the next lecture, we're going to have a look at this data structure, so see you next. Hello everyone, welcome back. This is Ahmed for Eduonix and this is Understanding Chef course. In this part of the course, in section 2, we are discussing tools of the trade, the tools that we are going to use in our journey learning Chef. In the first part of this section, we have discussed the Chef DK briefly, or the Chef Development Kit, and the Vagrant tool that is going to be used to launch virtual machines and use Chef to configure those virtual machines. In the second part of this section, we started working with Ruby, the programming language, and we started learning the basics of the language that are going to be used when writing chef recipes. At the end of the last lecture, we have learned that arrays are not the answer to your multiple values needs, because sometimes you may need to identify the values that are stored inside the array. And we have this example that we have a specs for a server, and those specs included the CPU speed, the memory, the amount of memory installed, and the amount of disk storage that this server has. And further on, we added another parameter that is the number of network cards installed on this system. And we said that arrays cannot solve the important question, which value resolves to which property. So 3 MHz can be figured out to be the CPU speed, but what about the 256 GB and just the number 2 that lies at the end of this array? It's just very hard to deduce or very hard to figure out. For this reason, we have the hashes, or for this reason, we have the hash. The hash is a data structure that is very similar to the arrays, but it gives each value a key. So it is a key value data structure. It uses the key to identify which value belongs to which property. So let's have a look at our example, and let's transform this example to something that can be figured out easily. I'm gonna just remove this and write specs equal and then open a curly brace. This is how hashes are defined in Ruby. You open a curly brace and then you start writing the key. The first key is speed, and speed here is 3 megahertz. Now I know that this is the speed of the processor. I can write memory. Memory is 16 gigabytes. I can write storage colon and 256 gigabytes. And finally, I can write, like for example, NIC, which is short for network interface card or network adapter, and I can write this as 2. Now, whoever reads this code will understand that I am talking about that 3 megahertz is referring to the processor speed, 16 gigabytes is referring to memory, 256 gigabytes is referring to the storage installed, and 2 is referring to possibly the amount of network cores installed. Now, if I want to return one of those values, if I want to use one of those values in other places of code, I can just use it like this, specs, and then open a square bracket, just like I did with the arrays, but this time I'm going to use the colon in order to specify this is a key rather than an index, and then write whatever value I want, or whatever key I want. Let's say, for example, specs, I want the network cards installed on this server. Let's save. And let's run, and as you can see here we have 2. We can even be more semantic and write the amount of NICs installed is, and as we learned, I can make a string interpolation by adding a pound sign or a hash followed by a curly brace and whatever value I want to be printed, and then close the curly brace and close the quotes. Now I can again execute this code and have the amount of NICs installed is 2. Of course, this is much better than using arrays. And let's say that you want to add another property or another value to this hash. You can simply do it like as follows. You call this the name of the variable, which is specs, followed by the key. Let's say I want to see how many cores are installed on the server, and let's say 4. Okay, so now the number of cores on the server is 4. Let's have a copy of this amount of cores installed is, and I'm gonna replace NIC with cores like this. If I run this code, I will have the amount of NICs installed is 2, the amount of cores installed is 4. Now I have successfully added a new property or a new value to the hash by specifying a key that I named it cores and assigning it a value of 4. Okay, and Ruby also has something called the syntactic sugar, which is the way some programming languages write shorthands or easier ways or more semantic ways to write complex code. So in our case, we can write the previous example as follows. I can say specs cores, which is something called a hash rocket, which is an equal sign followed by a greater than sign, and I can add the value and close the curly brace like this. Now I can write puts the number of cores on the server is, and then again I will use specs. This time I will have to surround the key with single quotes in order for this example to work. Save, and then when I execute the code, okay, I have a syntax error here. This is supposed to be a bracket. Okay, let's execute the code again. Okay, and let's run the code. As you can see here, number of cores on the server is 2. Now, let's see the difference between both methods. In the previous method, we have used specs equals cores equals, let's say, 4. Now, what is the difference here between this and that? Here, I have not used the single quotes. I have used the colon before the number and the equal sign and then the value. Here I have used the single quotes and the hash rocket and gave it the number right inside the curly braces. And this will also be reflected on how you call this variable. So in this case, I can't call it like this. I'll have to call it using the same way it has been declared. So I'll have to use the colon and remove the single quotes from around the key like this. Now let's run the code. And as you can see here, the amount of cores on the server is 2 on the first example, and the amount of cores on the server is 4 in the second line. Okay, and you can also use hashes of hashes, and although this sounds complex, it is used commonly in programming languages, and you can use it in Chef. Let's have a look at this. Let's say that now you have more than one server, and each of them is having its own specs, and you want to be able to call each server and examine its specs. So for example, I have a server for the DC or the data center, and I have another server in the DR or the disaster recovery side, and each of those servers has its own specs. I want to be able to use Ruby code to extract values for the server in the DC and the server in the DR. So in order to do this, let's write the code first. I will write servers instead of specs to be called servers, because now I am referring to servers rather than individual specs. Let's open the curly brace and let's write, for example, CPU is 3 megahertz. Notice here that I'm using the shorthand notation. Then memory, let's say 16 gigabytes. I can just copy and paste, and now the storage is 256 gigabytes. Okay, and now I'm gonna prefix this with a key, DC, and I'm gonna prefix also those values with a curly brace of their own. You see what we're doing? We see what we're doing here. We are placing the key for the first server to be DC, and this key, its value is another hash that contains the specs of the server. So DC, these are the specs of the DC, and this is just one item. I'm gonna have copy of this whole stanza, paste it, and just change the values accordingly. Here I am referring to the DR. The DR maybe is having 2 megahertz, it's having 8 gigabytes of memory, and it's having 128 gigabytes of storage. So here I'm having two servers, two keys. Each key is referring to a value, and this value happens to be another hash with its own values and its own keys. Okay, now let's first execute this code and ensure that no errors are being placed. Seems that we have an error. That is because, of course, we forgot to add a comma before memory. Let's run it again. Okay, and of course we also forgot to add codes around the DC and DR keys. Those are keys, those have to be surrounded by single quotes like this. Let's run again. Okay, this time we have no errors. Now I can examine whatever server I want, let's say the DR for example, and I can call whatever server I want, let's say for example the DR, and I want to refer to the memory installed on the server. I can refer to it like this. I'm referring to the key that is called DR, and inside this DR key I'm referring to the memory key that is inside the value of the server. It is just a way of placing multiple values for multiple entities inside a hash. Now let's save and run this code. And as you can see here, I have 8 gigabytes. That is the amount of memory installed in the DR server. So as you can see here, hashes are a very powerful data structure used in Ruby, and it is going to be used extensively in Chef, especially when we work with nodes. So you will have to have a good idea about hashes, how they work and how they are constructed in Ruby, and how they store data. And that brings us to the end of this lecture. In the coming lecture, we are going to continue working with Ruby. We're going to explore the conditional statements. So see you next. Hello everyone, welcome back. This is a new lecture in your course, Understanding Chef by Eduonix. My name is Ahmed, and in this part of the class, we are studying tools of the trade, or the methods and the tools that we're going to use when working with Chef recipes throughout this class. In the first part of this section, we have looked at Chef DK and Vagrant, which is the virtualization platform that we're going to use when working with virtual machines, and also the tool that is going to be used primarily for developing and testing the Chef recipes that are going to be later deployed to the node or to the Chef server. In the second part of the section, we have started discussing Ruby programming language, we are just scratching the surface. We're just giving the basics of the language that are going to be used with your Chef development journey. In the last part of the last lecture, we have seen how we used hashes in order to store multiple values in a key value way, and we learned how this can be incredibly important and incredibly useful when you want to store values that have property names. Like, for example, when we have, as in this example, you have servers, and these servers have names, and each one of those servers have its own properties, its own specs like CPU, memory, storage, and possibly other values. Storing it in a hash makes it easy to bring the value that you need for the specific server and the specific spec that you need to read. As you can see here, we had at the last lecture printed out the amount of memory installed on the DR server with just one line of code. Now, let's explore a different topic in Ruby, which is conditional statements. Conditional statements are available in all programming languages. A conditional statement is just a way to make some decisions while the code is being executed. So let's say, for example, that I have this code, CPU equals 4. Perhaps this is the number of cores that are installed, or whatever number you would regard. Most important thing is the variable of CPU is holding number 4. I can say if CPU equals 4. Now, and notice here that if I want to test for equality in Ruby, I'm gonna use the double equal sign. This means that if CPU does equal 4, if I use just one equal sign, this means that I'm assigning the value of 4 to the variable that is called CPU, which is of course not the case here. I want to test for equality. I want to test whether or not CPU does actually hold the number 4. So if CPU equals 4 bits, and notice here that this indentation is optional. You can just write code like this and it will work equally, okay? But I prefer indenting my code in order to be more readable. So I'll write, put this is a fast machine. Perhaps the CPU is 4, means that 4 cores are installed, or that the CPU speed is 4 megahertz or 4 gigahertz, and this means that it is a fast machine. Else puts or prints this is a normal machine. Okay, what this code basically does is that it tests for the value of that is held by the CPU variable, and if this variable happens to be 4, then this is a fast machine will be printed. Anything else that it encounters inside CPU, whatever it was, it will print the default message, this is a normal machine, and the if statement block with the end keyword. If you don't have this end keyword, Ruby will not know whether or not there are other decision-making statements that you want to put, whether or not there are other if statements that you want to add. So you have to terminate the if block with an end. Now let's save and run this code. Let's clear the screen and run this code. And as you can see here, I have this is a fast machine printed to the screen, which means that if has successfully read the value of CPU and it correctly printed the correct message. Now, what if I have more than one value or more than one decision that needs to be made? So let's say, for example, that I want to print if the CPU is 4, if the CPU cores or the CPU speed, whatever you want to regard it, is 4, I want to print that this is a fast machine. However, if this is 3, I wanted to print this as a normal machine, and if it is less than 3, I wanted to print this is a slow machine. So here I am adding another decision to the thread of decisions, or to the loop, or to the steps that need to be followed before the code finishes execution. So in this case, I'm gonna use the keyword else if. And notice here that else if is missing the e after the else. Some people get confused because in other programming languages, else if is written either as this or as this. But in Ruby, it is just written as this ELS followed by if. So else if, and I add the condition CPU, for example, is 3. I'm gonna print this is a normal machine. And finally, the catch all statement, the statement that will get executed if the CPU is neither 3 nor 4, puts this is a slow machine. Now let's say here that I have a machine with 3 cores or 3 megahertz, whatever. Then execute. I'll have this is a normal machine. If I have this at 1, for example, it's gonna print this is a slow machine. So it has correctly parsed all the statements, all the decisions, or the decision-making steps in the code, and it has correctly chosen the correct one, which is 1, which is this is a slow machine because CPU now is holding the number of 1. This is all basic, this is all straightforward, but what if the number of decisions is larger than just 2? What if I have 5 or 6 decisions that need to be made, and each decision is containing some code to be executed? At that point, the if statement will quickly become cumbersome and less efficient. In this case, I'm better off using the case statement. The case statement is designed just for this type of code. When you have multiple decisions, you have to the case statement will help you write down those decisions or those decision-making steps in your code. So let's say now that I have a company that is selling cloud services to clients, and it prices its products according to the downtime that is expected throughout the year. This is a very common practice that a company or a cloud provider gives you an estimation of the minimum amount of downtime that is expected throughout the whole year. This is a well-known feature, and you will often see something like this. Downtime is 99.99. You will often hear people saying, "I want the 5 nines or the 6 nines." This refers to the number of nines that is after the decimal point. Here I have a downtime of 99.99. This means that I can be up and running the whole year at 99.99 probability that I will not have a downtime. Some more expensive services or some more expensive plans have the 5 nines like this, so it's 99.999, and some even more expensive providers and more expensive services have the 6 nines like this, so it's 99.9999, which of course is a very, very, very low probability of a downtime that happens, and if it does happen, it's just a few minutes, no more than that. So let's say that I have now a downtime of 99.99. Let's say that this is the downtime that is expected by the client or that is accepted by the client. So I want to inform the client which plan does this downtime give him or her. Where does this downtime lie in the list of plans that the company offers or that the cloud provider offers? So I'm going to type case downtime. Case here is the keyword, and it's followed immediately by the variable that it is going to test. In our case, it's downtime. Then when, and then I give it the value against which it's going to compare or test for equality. So for example, when I say 99.1234, which is the 6 nines, the highest, I'm going to print that this is plan A. This is the most expensive plan. Let's say that when I have 99.999 only, which is the 4 nines, I'm gonna print this is plan B, which is maybe slightly less expensive. And when it is 99.99 only, which is 4 nines, I'm gonna put or print this is plan C. And then I want to put a catch-all statement. I want something that case will fall back to if none of these statements or if none of these decisions are correct. If this downtime is neither 99.9999 or the second or the third statement, if it's not equal any of those, I want a catch-all statement. Maybe if the client is okay with a plan that provides less than 99.99 downtime probability, that provides less than 99.99 uptime probability, maybe this is a development plan, and maybe this development plan is very cheap or even free because it does not guarantee the least amount of uptime throughout the year. And of course, if this is a development plan just developing, you're not in a production environment, you just want to test some code or test some functionality on the server, you won't be very concerned with the uptime or the probability of servers going down because after all this is a development environment, and you will be more concerned with the costs of this development environment. You will be more concerned with paying less because this is not the production environment. This is not your main work, or this is not your main line of work. So maybe this is the so maybe this is the catch-all statement. The client simply doesn't care about the uptime, probability. This may be a development plan, and of course you have to end any block in Ruby with the word end, the keyword end. So let's run this code as it is and see what it gives us. Okay, seems that we have an error here. Okay, we just place a single quote instead of double quote. My mistake. Let's run again, and as you can see here, this is plan C. That is because I have chosen a downtime or an uptime, if you wish to call it, 99.99. If I chose a downtime or uptime of 80%, which is none of what I have put, I will be just on the development plan. I simply don't care about how much downtime is being experienced by the servers throughout the year. So this is how you can use the case statement, and it's worth noting that case statements are not bound with equating or testing for equality of the variable. It has other cool features. Let's have a look at them quickly. You can, for example, put a range of values. So I can say, for example, if it is between 99.99 and 100, I'm gonna say that this is plan A. So anything that is between, okay, let's add those two nines. So even if there is another plan that is even more advanced than the highest plan, which will give you even more than 99.999, which will give you more than 6 nines, I can put it in this plan. This is plan A. This is gonna always be plan A. So I'm putting here a range of values between 99.999 and 100. So let's say here that I have something that has 5 nines. Okay, if I run this code now, I'm gonna see that I am at plan A even if I chose more than, even if I chose 7 nines, I will always be at plan A, because case here is examining a range between this number and 100. So as long as I am less than 100 and more than this number, I'm gonna fall into plan A. And case also offers you to have, like, for example, 99.999 comma 99 like, for example, I can have 5, 10, and 15. Of course, this does not fit into the example, but I'm just gonna tell you. But this is just a feature of case that I want you to be aware of, which is that it can test for equality on any of those numbers. So if downtime is equal to 5 or 10 or 15, if any of those numbers are equal to the downtime, it is going to print this statement. And again, this is not relevant to the example. This is just a feature of case that I wanted to show you. And finally, you can also use regular expressions when dealing with case statements. Regular expressions, if you don't have an idea about them, are just a way of searching through text. It's just an intelligent way of extracting and matching text using symbols that are specifically designed for this purpose. Let's say, for example, that I want to search for anything that has the number, followed by th. Like, for example, I want to test for 19th and 18th and 17th and anything that has an eth at the end, has a th at the end. If I want to test for that and I want to write something, if this is matched, I'm going to write those two slashes. Those in Ruby, in for Ruby, that I'm gonna write regular expressions, so it's gonna be treated as regular expressions rather than literal text. And notice here that I'm not using any quotes around the regular expressions, just the slashes. And I'm gonna start writing my regular expression. \d, and D stands for digit, plus stands for 1 or more. This means that I want to test for a digit, 1 or more digits that are followed by the literal th. And if this is a match, let's say I want to print this is a match, just anything. So if downtime value contained this, like, for example, 17th, okay. Now if I run this code, I'm gonna see that this is a match because the regular expression has correctly matched this string, which is 1 and 7. This is a digit, 1 or more digits. This is 17, followed by the literal th. So this is how case statement can match even against regular expressions. This is very powerful, and you're gonna find it a lot useful when you write recipes. And that brings us to the end of this lecture and to the end of this section in Understanding Chef by Eduonix. My name is Ahmed. I hope you enjoyed this section, and see you next. Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is Understanding Chef. In this section, section 3, we are going to start cooking. We're going to start writing recipes in Chef, and we're going to see the power of Chef, how it can achieve the configuration state of your machine to the way you desire. So let's get started. Well, almost all programming tutorials start with a simple example that prints the infamous phrase "Hello World" to the screen or to the terminal or to a file. So let's use this convention in Chef. Chef is a sort of programming language. We have mentioned this in the previous section. We have mentioned that it is one of the tools that achieve what's called infrastructure as code. We are no longer separating software development or writing source code files and the infrastructure that hosts those source code, the physical servers, the physical network adapters, and hard disks, and other parts of the infrastructure that holds these components and hosts those components. Now everything can be represented as code. Everything can be treated as code with the same elasticity, with the same mindset. Developers can build their own infrastructure and they can configure it the way they need, the way they desire, using code. So based on this, we are going to write a recipe for Hello World, same thing that is done in almost all programming languages. This is the first well-known example. So in the home directory of the Vagrant machine, I'm going to create a directory and call it cookbooks first. This directory is going to be used to host all our recipes that are going to be written in this class. It is going to host our first recipe, which is Hello World. So here we are at our Vagrant machine, and we are going to make a new directory that we're going to call cookbooks, like that. Let's cd inside that directory, and let's make another directory that is called hello-world. As a matter of fact, we could have written this command like this: make dir -p or -p cookbooks and /hello world. This is a shortcut that is well known to Linux administrators and users, but I have chosen to do it the traditional way in order to make things simple. Now let's cd inside hello-world, and let's create a file that we are going to call welcome.rb. And RB is short for Ruby, as we have mentioned in the previous section, that Chef is using Ruby as its programming language. It is a domain-specific language in this sense, and it is used by Chef. So, okay, Vim is not installed. I have destroyed and recreated this machine. Okay, I'm going to use VI like that, and I'm going to write the following. This is our first recipe. We're going to write file, then give it this path to the file that you want to work with. I have chosen /welcome. So this is going to create a file in this path /welcome. Then do, and do in Ruby, as we have learned in the previous section, defines a block. This is a code block in Ruby, so I'm going to start a block, and I'm going to specify content. And then between quotes, I'm going to write hello world. Then I'm going to end this block by writing the word end, the keyword end. This is a recipe, and before we explain what all these keywords and all these commands do, let's save our file. Okay, now let's execute this recipe. Sudo, and sudo, if you haven't seen this command before, sudo is used in Linux in order to run a command as root, or to run a command as the administrator of the machine. In our case, we are willing to run the Chef client or the Chef command using administrative privileges, because it is going to write a file to the root file system or to the /, and by default nobody can write to this path, nobody can write to this place other than root. So we are going to use sudo to run this recipe, and we are going to use chef apply. This is a command that comes pre-bundled with the Chef development kit. It is called chef apply, and chef apply is a wrapper around another command that is called chef solo. Chef solo is a command that is used to run recipes on the local machine. It is a command that is used mainly for testing recipes and, let's say, playing with recipes and trying them out before deploying them to the server or before putting them into production. So for this section, we are going to use chef apply in order to test our recipes. However, starting from the next section, we are going to use the command that is used by chef in real-world examples, in real-world scenarios, and in production environments, which is chef client. So for this section, we're going to use chef apply, and chef apply just takes the recipe name. In our case, it's welcome.rb, and I'm gonna press the enter. Okay, and as you can see here, we have an interesting output. It said that created a new file that is called welcome, and it updated the content in this file from none to, and it's giving you some hash. It's giving you the date and time of what it did, and then it is giving you an indication of the text that was written to the file, plus hello world. This means that it has added this text to the file. Let's see the contents of the file that has been created. Let's first ensure that there is actually a file that is called welcome that has been created in the root file system. And yes, we have a file that has been created. It's called welcome. If we get this file, we're going to see that it contains hello world without a new line at the end, just the text hello world. Congratulations, you have successfully created your first chef recipe. Now, let's examine the anatomy of this recipe. Let's examine what exactly has been done when we wrote this recipe. I'll always forget that I don't have Vim installed. Okay, now have a look at the first line in this recipe and the first word of this recipe. It contains the word file. File here is called a resource. In Chef, this is called a resource, and Chef contains a large number of resources that are used to manage different tasks on the system. Like, for example, it has resources to install packages, uninstall them, manage files as the file resource, manage services that are running on the system, in addition to many other resources that are available at the Chef official website. We're going to have a look at this website in a moment. So it is docs.chef.io and then resources.html. If we navigate to this page, resources.html, you're going to see that we have a lot of resources here on the left-hand side of the page. All these are resources that you can use in a chef recipe in order to manage, as we said, different aspects of the system. Let's have a look at the file resource that we have just used. Just click on the file here, and we're going to have a look here at the syntax. As we have seen, this is the file resource, and it is always followed by the path of the file that you want to create. In this case, or in this example, Chef is demonstrating how you can create an index.php file in your website, your default website. Then it is followed, as we said, by the do keyword, and as we said, the do keyword is marking the start of a block code in Ruby. Then the second line, let's return back to our example. The second line in the recipe contains an attribute of the resource. This attribute here is called content. Content here is one of several attributes that can be used with file. If we return back to the resource page, you can see that we have more than one attribute that can be used with file. We have mode. This is the mode of the file. If you want the file to have special permissions, you can specify that in the mode. Of course, Chef will use by default the default settings of creating new files on the system. And if you are a Linux administrator, you may know that this is set by something called the umask that is specified in the profile of the user or in the global profile of the system. However, if you want to override this umask, if you want to create the new file with special permissions other than the default ones, you can specify that in the mode attribute here. And also you can specify the owner and group of the file, as we're going to see in a moment. You can specify that this file can be created using another owner than the user that run the chef command. In our case, the user that run the chef command is root. So by default, this file is going to be created to be owned by root and by group root, but this can be overridden using these attributes. Okay, so content is one of the attributes that can be used with file, and we have used it here in order to insert content into the file. Okay, then you end the block by the keyword end that we have seen before in this class. It just marks the end of the block, and in our case, it's the end of the recipe. And now we have the what's called the $1 million question, which is, couldn't I just have used bash for this? In other words, why shouldn't I have used simple shell script for just writing content to a file? If you've been using Linux for a while, you know that you can just clear the screen. You know that you can easily do what have been done here by just echoing hello world like this, and then redirecting the output to a file that is called welcome, and it is going to, okay, just use sudo again, okay, and it is going to do the same thing. It is going to write hello world to welcome, or it is going to write, and notice here that it has added a new line because we use the command echo. Command echo by default adds a new line. Anyway, I could have used any of the bash commands in order to write that same content to a file. So what did chef do for me? Why should I use chef for these commands? Well, even in an overly simple example as printing hello world to a file, chef is a better choice, and here is why. If you will use bash to achieve the same result, you would write a line of code as follows. We have seen that, echo hello world to and redirect to /welcome. Now, let's say that writing this file is part of a long configuration process that put the machine in a specific state. You need to put the machine in a specific state and maintain this state. And this is the essence of using configuration tools. This is the essence of using a configuration management policy, which is that you need the machine to be at a state and remain at this state. If it deviated from that state or from those requirements, the configuration tool should move the machine back to the way it was. So it's not just about writing files, it's not just about inserting content, it is about maintaining the state of the machine. Let's explain this a little more. To do this, you simply run the script only to. So what if this machine deviated from that state? In other words, what if I open this file at any point in time and see that it does not contain the hello world phrase that I needed to contain? I needed this file to contain the phrase hello world. What if in some point in time I found that this file no longer contains hello world? In this case, I will simply run the script again to overwrite whatever text was in the welcome file, overwrite the content that the /welcome file had with hello world again. Or maybe writing to this welcome file is part of a long script. It is part of a long configuration policy in which writing hello world to /welcome is only part of this process. It's only part of it, it's not everything. Maybe I needed to install some packages, create some users, write some settings to some configuration files, and then through this process, I'm going to also write the phrase hello world to /welcome text file. So if this configuration has changed, if the machine deviated from this configuration state, I will simply run the script again. And running the script again will simply, as we said, it will simply overwrite the whatever content was in the /welcome file and replace it with hello world. So what's the problem in that? The problem is that you are unnecessarily doing work. You are changing the timestamp of the file, to say the least. One of you might argue that you can use some shell commands in order to examine the file before writing to it. Just examine the file to see if it does contain the phrase hello world. So it's gonna overwrite it. If it doesn't, and if it does, it will do just nothing. It will just pass on this file and continue to the next step. But this means a lot of code to write, and as long as your code the longer your code, the more difficult it is to maintain and the more errors it is prone to. Besides, comparing the syntax between a shell script code and Chef's code shows you how Chef is more semantic and understandable even to non-developers or non-system administrators. This makes a Chef recipe by itself a way of documenting your configuration even without using comments. And of course, the most powerful feature of Chef is the ability to control hundreds of nodes through one central server, a feature that is naturally not available in a shell script. So in short, Chef will run the same task as the shell script, but with more semantic code. It can manage multiple nodes at the same time using Chef server, which we are going to study later in this class. So back to our example. Compare this line of code, let's have a copy, to this. Compare this line of code to this recipe. This line of code is not understandable except for a system administrator that knows what these commands do, that knows that sh here is opening a new shell, and -c is used to execute the following command in the context of this shell, and that echo is going to output whatever follows it to the screen, and then the redirect sign is going to take whatever is going to be printed to the screen or to the terminal and is going to redirect it to a file, and that eventually this text is going to go to this file that is /welcome. Imagine how hard it is for a non-system administrator to understand this line of code compared to this. File, then a path, then do content, hello world. It is very self-explanatory. It's just telling you that this file should contain this phrase, hello world, okay? And notice what happens if we try to run this recipe again. So we run the recipe again. Let's examine the contents of welcome. As you can see here, it returned the text back to the way it was. Because as you can see here, Echo has added a new line after the phrase, but the original file that the recipe created did not contain that new line. So for Chef, this is the difference, that it needs to revert back. So it returned the file back to the way it was, which is containing hello world only with no new lines. Now, what if I try to run the recipe again? As you can see here, now it has no messages that indicate that something has changed. Here in the previous run, it said updated content in file /welcome from, and it's giving you a hash to the original hash. This is, remember, if you remember from the previous or from the first run, this is the hash of the file. This is the hash that Chef gave to the file after it wrote hello world and a new line at the end to the file. So it wants to return the file back to this hash once it examines the file and it finds that it contains a different hash, which is this one. A hash is just a symbol or a group of characters that define the state of a file. The moment the file changes, this hash changes. Even if one letter has changed in the file, even if a new line has been added to the file, this hash changes. So Chef examines this hash, and if it is different than the one that the file should have, it is going to examine the contents of the file and it's going to overwrite it again. However, if you try to run this recipe again after the file has the correct hash, has the correct or the exactly correct content, it will not reapply the recipe. It will not change the file timestamp. It will not overwrite the file. It will just do nothing. It will just pass on to the next step. So as you can see here, Chef is much more powerful than shell scripts, and Chef even allows you to use shell scripts, as we're gonna see later in this class. You can use Chef resources to execute direct shell commands inside a recipe, so you can have the best of both worlds: the power of Chef in configuration management and the power of shell scripts in order to execute complex tasks that need special commands that cannot be offered except by a shell script. You can use the best of both worlds to achieve your desired requirement. And that brings us to the end of this lecture. In the coming lecture, we are going to be introduced to version control, how you can track your files using a version control system. And this is very well known in programming languages. And as we said, Chef is no different now than any programming language. It uses source code files to configure your infrastructure. So we are going to use version control the same way we do with traditional programming languages. And that will be the topic of our next lecture. So see you next. Hello everyone, this is Ahmed again, and this is Understanding Chef by Eduonix. In this part of the class, in this section, we are writing our first recipes, we are getting our hands dirty, and we are starting to see the power of Chef in configuration management. Although we have just written a very simple recipe that just wrote some text to a file, and it ensured that this file will contain this phrase or this text the way it was written, and we saw how Chef brings back the machine to its desired state if it deviated from that state, and if it is on the desired state, Chef just does nothing. Now let's have a look at a slightly different topic here, but it's very important if you are going to write serious Chef recipes, which is using version control. One of the merits of using infrastructure as code is that you deal with your infrastructure the same way you deal with your source code files. If you're a developer, developers tend to use version control to various versions of their code files so that they can test changes, roll them back, quickly switch from one version of the file to another, collaborate with other developers, and so on. Of course, the advantages of using version control are more than they can just be listed in this part of the lecture. However, it has a lot of benefits. It can be used as a backup. It can be used as a way to test changes and then revert back to your state without destroying your code or without messing with any settings that are hard to get back. Version control is for anybody who uses source code files, and it is an indispensable choice. Your Chef recipes are nothing more than a source code file written in Ruby. We can use a version control system to manage it. In this class, I'm going to use Git, and Git is one of the most famous version control systems in the market. However, if you want to use other version control systems like Subversion or Mercurial or others, feel free. Git does not ship by default with Bento CentOS machines. This is the version of the Vagrant machine that we have installed. It is a Bento CentOS version 7.3, and Git does not get installed by default, so we are going to install it by using yum. So let's get to our machine, let's clear the screen, and let's run yum -y install git. Okay, and since I am not root, so I need to use sudo for this to work. Let's give it a few seconds to complete. Okay, so Git has been installed successfully. And in order to use Git, it's very easy. All what we need to do is actually two things. The first thing we're going to do before even using those two things is to initialize our repository. Initialize the repository means that you want Git to be aware that you are going to track files in the current directory. So I'm doing this. So this is called Git initialization, and it can be done using Git init like this. And pressing enter, as you can see here, I have initialized an empty Git repository in /home/vagrant/cookbooks/hello world/.git. And .git here, if you have a look, this is a file. This is a hidden directory that does not show by default when you type ls, except if you passed in the hyphen, if you passed in the -a option, which shows hidden directories. And this directory includes some binary files that are used to store the changes or to track the changes of your files that you want Git to track for you. So in order to track files, in order to track changes, we're gonna do two things: Git add, followed by the file or the files that you want to add or that you want to track. And a very common shortcut for this is to add just an asterisk. An asterisk means I want to track all the files in the current directory rather than having to manually add one file after the other. So I can just add welcome.rb, but for the sake of simplicity and for the rest of this class, we're going to use just git add followed by an asterisk. Okay. Now the second command that we are going to use is actually committing those changes, committing those files with their state to the repository, so that we can revert back to them if something wrong happened, or if some settings in those files have been destroyed or messed up. So I'm gonna write git commit. This is the commit command -m, and m here is short for message. This means that I need to pass in a message to Git in order to show why I did this commit. What did those files contain? What was the state of those files, and why I want to track those files, and why I want to store this state at this moment. By convention, most developers start with something called initial commit. This means that this is the initial state of the files, after which I'm gonna do changes, and those changes are going to be further tracked by Git. So I'm gonna add git commit -m initial commit. Okay, and here it's just giving me this warning that I need to add a name and an email. This is, of course, because Git is a collaboration tool, so it is expecting that you will work with other developers. So you need to identify yourself by adding a username and an email so that other users can have a look at your changes and can collaborate with you, and so on and so forth. In our case, I'm just working alone on this Vagrant machine, so I'm not going to add a username or an email. Okay, and now if I run git status, this is just one of the monitoring commands, or one of the commands that shows the current status of Git. If I run git status, I'm going to see that nothing to commit, working directory clean. This means that I have no changes to the files. No changes have been done to the files. If I type git log, I'm going to see that I have an initial comment. This is the date of the comment, and this is the hash of the comment. This means that I can return back to this comment. I can return back to the state of this file whenever I want. This means that I can test this recipe. I can add a lot of other resources, a lot of other attributes, play with them, test them the way I want, and then I can revert back to my original state of the file whenever I want by going to this commit. Or I can commit those changes if I determine, or if I decide that they are useful and that I want to go ahead with them. I can just commit those changes, and now I have two versions of my file, the initial commit and the version of the file where I have added more recipes and more code. So I can move back and forth between both versions, and I can also have other developers or other system administrators collaborate with me in this work. So this is the power of Git, and we are going to use Git throughout this class. Whenever we add new recipes, whenever we change the recipes that we are using, we are going to use Git to track our changes. Now, let's have a look at the attributes. So far, we've seen only one attribute, or sometimes it's called property, of the file resource, which is content. But Chef is capable of much more than that by using other attributes. Let's have a look. You can specify the owner and/or group of the file by using the owner and group attributes. We have briefly seen this in the previous lecture when we examined the resources page of Chef, chef.io, and we have seen the file resource, the example that Chef used also an owner and a group and a mode of the file, which refers to or which is reflected to the permissions that are going to be given to the file when it is created. So here I can change the file to have a group and an owner of Vagrant. Let's have a look and see how this can be done. So let's have a look at our recipe again. And I will add an owner of Vagrant. And Vagrant is the default user that gets created with any Vagrant machine. Vagrant user and Vagrant group, these are the default user. This is the default user and group that gets created with any Vagrant machine. We are going to change the owner of this file that is called welcome to be owned by Vagrant user and Vagrant group instead of the default root. Let's save, and don't forget to track your changes by running git add asterisk, then git commit -m, and I can add here a descriptive message, change it owner and the group to be Vagrant, like that. Okay, now let's clear the screen and let's run this. Then let's run the recipe using chef -apply and again welcome.rb. And notice what the output of this. Okay, I forgot I have to use sudo to run this recipe. That's why Chef gave me this error, and notice here carefully what is printed. It just changed the owner from root to Vagrant and the group from root to Vagrant, but it did not write any content to /welcome. That is, as we have mentioned in the previous lecture, that is because it examined the content of welcome file and it determined that this content should not be changed because it is exactly how the recipe wanted it to be. So there is no content that has to be created again. There is no content that has to be written to the file /welcome. But because the user and the group were different than the desired one, which is Vagrant, then it changed owner from root to Vagrant and the group from root to Vagrant. Let's double check that this is what happened. Yes, we have the Vagrant user and the Vagrant group owning /welcome file. That's just amazing. Now, let's examine the package resource. Within any configuration management policy, there should be packages that need to be installed or uninstalled. Chef provides the package resource for managing different packages on your system. Let's say that you need to install a web server for your development node. On CentOS, the Apache web server package is referred to as HTTPD. This is the name of the package when you use the package manager of CentOS, which is yum. When you want to install HTTPD or the Apache web server, you use yum install and then you give it the name of the Apache server, which is referred to in the yum repositories as HTTPD. On Debian systems or Ubuntu, this is referred to as Apache 2. This is very important to notice because if you want your recipe to be interchangeable between different Linux machines, you'll have to be very sure about the packages that you intend to install and how those packages are named in different repositories. So, as we said, on CentOS it's called HTTPD, and on Ubuntu it is called Apache 2. So, let's write a recipe that will install the HTTPD package on a CentOS machine. So, here in our hello world, let's create a new recipe. Let's call it web server, for example. webserver.rb. Okay, again, I forget that I don't have Vim installed. And then I have the package resource, and I give it the name of the package. As you can see here, all the resources or all the recipes in Chef have a similar way of writing. You have the resource followed by the attribute of that resource, and then do to define the block, and then you give it an action here. The action here is called install, and then you end the block. And notice here that I've written install prepended with a colon. This is how Ruby or how Chef refers to actions. This is a key. If you are a Ruby developer, this is a key that is used by Ruby to define just a symbol. In our case here, this is called install. So Ruby, somewhere in the code, it's going to take this key and use it to execute a command behind the scenes. In our case, of course, it is the yum command. It is going to use it to install the HTTPD package on the system. So let's save the file, and again let's add our changes, git add asterisk, and then git commit -m or -m, and then let's say created a recipe for installing Apache web server. Okay, let's clear the screen and let's run sudo chef -apply and web server .rb, and let's observe what happens. As you can see here, it has used the yum package manager to install the httpd package. As you can see here, the action is install, and as you're going to learn, we can have other actions than install that can be used in a recipe that uses the package resource. Okay, and now we have installed this version of Apache 2.4.6-45 for CentOS. If you want to make sure, you can run the rpm command, rpm-qa, and then you can grab the name of the package that you want to search for, which is the httpd. As you can see here, it is installed with its dependency http-tools. And that brings us to the end of this lecture. In the coming lecture, we're going to see how we can maintain the state by not only installing packages or writing files, however, sometimes we need to deinstall or to remove files from the system. So, see you next. Hello everyone, welcome back. This is Ahmed for Eduonix, and this is Understanding Chef, Section 3. Let's write some code, or let's write some recipes. In the previous lectures, we have seen how we can use chef to bring a system to the desired state by running the chef apply command and giving it a recipe. In the previous lectures, we have seen how we can create new files. We have seen an example of the resources, the file resource and the packet resource. However, at the end of last lecture, we have said that maintaining state is not just about installing packages or writing files. Sometimes we need to deinstall packages. Let's have a real-world example for this. In modern enterprises and in large enterprises, the security policy enforces the system administrators to remove packages that are considered a security threat, or that are considered should be removed if not strictly needed. And among those services is the telnet service. The telnet service has long been used, like 10 years ago or maybe more. It has been used for system administration. If you want to log into a remote machine, you use the telnet command, and the telnet command connects to a telnet server or a telnet service that is running on the remote Unix or Linux system. And once you are connected, it gives you the login screen, and you enter the user and a password, and you are logged into the system. You can run whatever commands on the shell of that system as if you are sitting in front of the server, as if you are sitting right at the server. However, you are logging in remotely. The problem with this service is that the user and password and any information that is passing from you, the administrator, to the server, and the other way around, are sent in plain text. This means that any hacker or any attacker can just intercept those packets, can just intercept those data, and steal important information from that connection. Of course, that is a major security threat. So in all modern enterprises, telnet service is completely disabled, and some security policies enforce that the service is completely removed from the system, not just disabled. So using chef, we can quickly write a recipe that will ensure that both telnet and telnet client are both uninstalled or removed from the system. You might ask yourself, why did you install it in the first place if you know that it is not needed? Well, telnet and telnet client get installed by default in any Linux installation. Even if you chose the minimal installation, they get installed by default. So let's quickly write a chef recipe that will ensure that both of those services are not installed on the system. So let's write here a recipe that, let's call it compliance. since we are trying to comply with the security policies of our enterprise or of our company. And let's write again a package resource. But we have here two ways. We can either write a package and then pass telnet and then write the action that you want to be executed. In our case, it's remove, and then write another package and call it telnet client and redo all what you and rewrite all this code again. Of course, this is a waste of keystrokes and a waste of time. Instead, we can use the Ruby language. To speed things up a little. Let's see how we can do that. We can create an array. We have talked about arrays in the last section when we studied a little bit about Ruby. We said that arrays are nothing more than a collection of items. They could be strings or numbers or any items that are used by Ruby. In our case, we are going to create an array of strings. Those strings are the names of the array, the names of the packages that we need to uninstall. In our case, they are telnet and telnet client. Then we are going to use the each method. Each method is one of Ruby's methods that work extensively with arrays. They just loop through the arrays. It is as if I'm telling Ruby I want to loop through this array to have a look at telnet and telnet client and execute something on each one of them. So hence the name is called each. Then of course do in order to start a block. And this time I'm gonna pass in a variable in those pipes. P here is a variable, and P here will represent each of those items. It is as if I'm telling Ruby I want to execute whatever I want on telnet and telnet client, and I want you to refer to each one of those as P inside the code block that I'm gonna write. So I'm going to now write the package, the normal recipe, as if I'm writing it from scratch, but instead of passing in telnet like this or telnet client, I'm gonna pass the P variable, and because this is a variable, I'm not going to enclose it in single or double quotes. Remember in the previous section when we have studied strings, and we said that strings are always quoted either in single or double quotes, but variables are not quoted. You want Ruby to interpret P as a variable and not as a literal P. And again, I'm gonna write do, which is the start of a block. Then I'm going to write the action that is remove. Then I'm going to end the first block and the second block. Again, this is a loop. Again, this is an array. An array is a collection of objects. I'm putting here two objects or two items, telnet and telnet client. These are the packages that I want this block or this stanza of code to run on each one of them. So I'm using one of Ruby's methods, which is called each, and for each to work it has to be passed in, and for each to work it has to be passed a variable on which it will work, on which it will substitute for the item that it's going to work with. So in the first iteration it's going to substitute P with telnet and execute that action on it. On the second iteration, it is going to substitute P with telnet-client, and again, it is going to execute that action on it, which is remove. So let's save this, and again, never forget to track your files. Git adds asterisk and then git commit -m added a recipe for removing telnet and telnet client. Okay, and then let's clear the screen and let's run chef client, or sorry, chef apply, and then give it the name of the recipe, which is compliance. And again, I forgot that I need to run this using sudo. Should never forget that because I'm not root. Now sudo chef-apply compliance, as you can see here. Okay, and seems that telnet and telnet client are not installed, so I'm going to install them quickly first. Seems that this Vagrant machine does not have telnet and telnet client installed by default, So I'm going to install them quickly. Okay. Now let's clear the screen, and I'm gonna run this recipe again to ensure that both of those packages are not installed on the system. As you can see here, it is removing telnet, remove package, telnet. Okay, and telnet client did not get installed in the first place, maybe because it is not available. And as you can see here, it removed the package telnet, and actually telnet was not available on the system at the first place. So it did not remove it because it did not find it. So as you can see here, it's up to date. The system here, or Chef is considering the system as up to date because the package is not installed. But if you want to see this in action, I can remove, for example, the HTTPD package. So instead of telnet client, let's remove the HTTPD package that we have just installed in the previous section. Let's reinstall again that we have installed in the previous lecture. Let's install again telnet to let the recipe deinstall it again, just to see the power of loops in Ruby. Let's run the recipe again. And as you can see here, it has removed telnet and then removed HTTPD. If you run now rpm -qa and grep HTTPD, you'll find that the HTTP tools only is installed, not the HTTPD package. Maybe we should also remove HTTPD-tools in this recipe, and telnet is no longer available. So as you can see here, I can maintain the state not only by installing packages, but also by removing packages. The most important task of Chef is maintaining the state, or keeping the machine at the desired state, whatever that state may be. Maybe some packages were not installed, so they need to be installed. Maybe some packages are not supposed to be installed on the system, so they need to be deinstalled. And maintaining state may also entail deleting files. We have seen so far two resources, which is file and package. We have seen how we can use package to install and deinstall packages. Let's see how we can use the file resource to also delete files. The same way we use... Okay, so we can write a recipe to delete files from the system. Let's have an example. Let's say that I want to remove the /welcome file that I've just created using the first recipe on the system. Okay. And okay, we are going to write a resource that is called file. I'm going to give it the path to the file, which is /welcome. And then instead of content, we are going to use the action. And the action here is going to be remove, then end. And again, you can add here a number of files by using an array and passing in the .each method at the end, the same way we did with the packages. But in our case, we just need to remove just one file, so we needn't use an array for this. And now let's git add everything again, and git commit -m added a file resource to remove /welcome. Okay, then let's clear the screen and let's use sudo chef apply the compliance recipe again. And notice that I did not hash out or delete. Okay, maybe there is a syntax error in the compliance. Okay, I forgot to add do. And notice here that I did not hash out or remove the file, the lines of the recipe that I'm sorry, the action is delete, not remove. Remove is for packages. Okay. And notice here that I did not hash out or delete the other lines of the recipe that used to delete or reinstall HTTPD and telnet, because as we said previously, Chef will not do the action twice. If telnet is not installed, it will not bother and call yum to deinstall this package. It will just pass on to the next step or pass on to the next task in the recipe. As you can see here, telnet is not installed, so it's up to date. HTTPD is not installed, so it's up to date. But welcome is present, /welcome is present at this path, so it will delete this file, delete file /welcome. So now if I have a look at /welcome again, I'll find that no such file or directory. So Chef has successfully retained our machine to its desired state by running the compliance recipe, which deinstalled telnet and the HTTPD service, and it also deleted the /welcome file. In the coming lecture, we are going to have a look at one amazing tool that gets installed and shipped and ships with the Chef development kit, which is called Ohai My Machine, which is called Ohai the Machine Inspector. So see you next. Hello everyone, welcome back. This is Ahmed again for Eduonix, and this is Understanding Chef. In this section, we are getting our hands dirty and we're starting to write the first recipes. We're starting to see how Chef is so powerful at retaining the machine state, is so powerful at ensuring that the machine does not deviate from the configuration state that we need it to be at. In the previous lectures, we have seen how we can use sample resources of the large list of resources that are used by Chef. We use the package resource and the file resource not only to install packages and write files to the system, but also to deinstall and delete files from the system. The most important thing is to make the machine return to the state that is desired by the administrator or the developer. Now let's have a look at Ohai tool. Ohai is a tool that gets installed with the Chef development kit. It grabs large amounts of information about the running system, like CPU, memory, kernel settings, installed programming languages, and even the uptime of the machine. You can run it as a standalone tool by running Ohai on your terminal, and the output is in JSON format. Let's run Ohai on the system and see what the output is like. So here on our Vagrant machine, I'm going to clear the screen and I'm going to write Ohai, just like this. It will take a couple of seconds to complete, and it is going to give me this large amount of text that includes a lot of information about the machine. As you can see here, I have the installed packages, I have the kernel, the architecture, I have the machine ID, I have information about the installed memory, I have the most detailed information I can have about the machine. You have the host name, the machine name, the fully qualified domain name, everything about the machine, the disks that are installed. Just everything that can be grabbed about a machine can be installed. Just everything that can be grabbed about the machine is listed in this Ohai output. So how can I use Ohai in my recipes? How is Ohai of any importance to me? Each time Chef runs, Ohai runs as well to grab the latest information about the running system. You can utilize Ohai inside your recipes by using the node hash. We have studied hashes in the previous section when we studied a little about Ruby, and we said that hashes are nothing more than a key value set of items. Each item is going to have a hash or a key, by which it is going to be identified. It's the same thing as arrays, but the difference or the main difference between a hash and an array is that arrays use indices to identify the items that are stored. However, hashes use keys to identify the items that are stored inside it. So the node here is just a hash, and you use keys inside this hash to grab information. So let's have a look at this interesting example. We are going to use chef to write a file that is called specs, and this file is going to contain information about our machine. In particular, it is going to write the total amount of installed memory. So let's have a look at our example system. Let's clear the screen and let's create a recipe that is called specs. Okay, so let's write here a file resource, and the file will be named specs, and it will be written at the root of the file system. Then do, and the content of this file is going to use the node. And notice here how I'm using the pound sign or the hash followed by the curly brace, and we have seen in the previous section that this is called string interpolation. This means that I want this code to be executed rather than being written literally to the terminal. So I'm running here node, and I'm specifying that I want to have a look at the memory key of this hash. And remember, in the previous section we have seen that hashes can be nested. I can have one key that is referring not to an item, not to a single item, but to a whole other hash table, a whole other collection of items that are also stored in key value pairs. So I'm referring here to memory, and memory by itself is containing a lot of key value properties or pairs. I'm going to have a look at the total key, and this will give me the total amount of memory that is installed on this system. Then I'm going to end, and of course I'm going to use git to track the changes. Git added a recipe for recording the total amount of installed memory. Okay, now let's clear the screen and run chef apply and specs.rb. Of course I have to use sudo because I'm gonna write to the root file system, and let's see what chef will give us. Okay, as you can see, it created a file that is called /specs, and inside this file it wrote this number. This is the total amount of installed memory on this Vagrant machine. It's about 1 gigabyte of memory. It's written here in kilobytes. So if I examine the contents of /specs file, I'm gonna see that I have this number printed. It's just 1 gigabyte of installed memory. Now, this is the last slide in this section. The rest of this section is a bonus one that shows you how you can use the power of Ruby to have even more control over the output of the recipe. Understanding the coming slide is not mandatory to understand chef. So if you are not interested in Ruby as a language, or if you're not interested in how you can use Ruby as a language to enhance the output of chef and to even have more control on chef, you can just skip ahead to the next section, because understanding this part of the section is not mandatory. It's not obligatory to understand chef. You can just go ahead with chef, write recipes without having to be a Ruby developer. So if you are not interested in Ruby, you can just skip ahead to the next section. If you want to learn more about Ruby and see how you can have more control over the output of your recipes, just follow along. Hello everyone, welcome back. This is Ahmed for Eduonix, and this is Understanding Chef, Section 3. So, Ruby's show of force. In the previous recipe, we created a file in which we recorded the amount of memory installed on the system, but this output had some issues. First thing is that it calculated the amount in kilobytes. Most systems nowadays have multi-gigabytes of memory, making this a large and unreadable number. Let's have a look at the number again. As you can see here, this is large and unreadable. It's ugly. We need to enhance it a little. So let's use Ruby's command to fix that. We need first to divide this number by 2024 to convert it to megabytes. As you can see, as you of course know, 1 megabyte is 1024 kilobytes. So in order to convert this number from kilobytes to megabytes, we're going to divide it by 1024. And then we can even divide the resulting number by 1024 again to convert it to gigabytes. To do this, first thing we have to do is to get rid of this part of the output, which is KB or kilobytes. Because if we use this number just like this and divide it by and asked Ruby to divide this number by 1024, it would just output an error. Why? Because Ruby sees this number as a string rather than a number. Why? Again, because it has KB appended to the end. So Ruby sees a number followed by a string, so it interprets the whole number as a string rather than a number. So in order to instruct Ruby that this is a number that can be calculated and that can be used in mathematical operations, we need to remove this KB part of the number. So how we can do that? Let's have a look at the recipe. And Ruby has an interesting way of dealing with arrays, which is slicing. And slicing, as the name implies, means just removing parts of the array and printing the rest, or printing just part of the array. And because a string is just an array, Ruby treats strings as an array of characters. So the number that we have seen followed by kilobytes is just an array of strings, or an array of characters that can be sliced. So how can we slice an array? Let's first see how we can print a single character of the array. So if I added here a square bracket and I put 0, 0 here means the first character of the array. And the array here, as we said, is the whole string converted to characters. So if I just put 0 here, this means that I want to print the first character of this number, or of this string, if you wish to call it. Let's run the recipe again and see what the output should be. Okay, as you can see here, it just printed 1. Why? Because 1 is the first character of this array. As you can see here, it's 1. So what I want to do is that I want to print from the first character of the array just to the last 3 parts of the array. I want just to remove the KB part of the array. So I'm going to move 3 places from the left. Let's save and see. I want to be 1, 2, and 3. I want to be here. And because I'm using a zero-base array, so the length of the array, if you recall from the last section, the length of the array is n minus 1. The last item in the array, the index of the last item in an array, is the length of the array minus 1, because the first item in the array of 0 is 0. So if I want those KB characters to be removed from this array or from this string, I have to enter 0, then ... minus 3 in order to get to just after the 6. The same thing I did here. I'm just slicing this array to be starting at 0 and moving all the way till the end, except that I don't want the last 2 characters. And again, because this is a zero-base array, I'll have to add 1 to the total number of items that I want to remove, so it is minus 3. Let's run this and see what it gives us. So as you can see here, it is the same number, just without the KB at the end. If I cat specs again, I'm going to see that this is the number, but without the KB at the end. That's amazing. Now I can use chef commands in order to divide this number by 1024 and give the resulting number in megabytes. So how can I do this? The first thing I have to do is that I need to convert this whole number to float. If you are a programmer, or if you have learned about programming before, you will know that a floating point number is a number that contains decimal places. It is a number that is not an integer, it is not a whole number, it is a number that can accept decimal places. And of course, in any memory representation of any machine, you will almost always find a decimal place. You will never find a memory that is just 1 gigabyte or 10 megabytes. You'll always find some fraction that needs to be added to the end of the memory. So I need this to be a floating point number. And fortunately, Ruby has its own method of converting a number to floating point just by appending a dot. And a dot means that I want to apply this method or this function to whatever has been printed. So this is just as if I'm telling Ruby that I want the number that is resulting from this operation to be converted to a float and then divided by 1024. And I can even divide it again by 1024 if I want this resulting number to be in gigabytes. Now let's save, clear the screen, and run again the recipe and see what it gives us. Okay, as you can see here, the conversion is successful and I have here 0.96. This means that I roughly have 969 megabytes of installed memory. But have a look at this number. This is a large number. It is largely unreadable. It is the same thing. It is as if I did nothing. I'm just reverting from one large number that is unreadable to another large number that is also unreadable. So how can I use Ruby in order to further enhance this? This is the job of another Ruby method that is called round. And in order to use round, I will have now to surround the whole expression in rounded brackets. Why? Because I want round to be working on the output of all this expression. I want round to work on all this expression. I'm sorry, I have to put this rounded bracket after the curly brace like this. So I want round to work on the result of all this operation. After I remove the KB part from here, convert the number to a float, divide the number by 1024, and divide the number again by 1024. After all this operation is complete, the resulting number is going to be rounded to 2 digits, like this. This is going to round the number to the nearest 2 digits. Let's save, and let's run again the recipe and see what it gives us. Okay, that's nice. It's giving us 0.97, which is the correct rounding for this number. It's about 970 megabytes of installed memory, or 0.97 gigabytes. Let's see that this number, let's ensure that this number is printed to specs. Yes, it is printed. Let's clear the screen. Now, let's have one last enhancement. Let's add a gigabytes or a GB part to the file. Remember, we removed the KB part of the number in order to be able to divide it by 1024 and to do mathematical operations on the number, but we want the resulting number, or the final result, to have the label, or to have some identification for the reader. We need the reader to know that this is measured in gigabytes and not in megabytes, for example, or kilobytes. So we need to convert this again to a string, and Ruby has its own method of doing this. It is a method that is called to underscore s. So see what I'm doing here? I am taking the output of the round and I am converting it to a string. Okay? I know that this is becoming more complex, but again, this is not mandatory to understand chat. This is just Ruby enhancements to better understand, to better control, or to have more control about your recipe. And I can add a plus sign for concatenation. And concatenation in strings means that I want this string to be added to this string, which is GB. I can finally add a new line character like this, just to ensure that the output will be much more readable to the reader. So again, let's have a quick look at what we did. We are using content as an action or an attribute for the file resource, and we are using the string interpolation. And we have covered this in the previous section. We said that string interpolation means that I want Ruby to execute whatever code is between the hash sign, the curly brace, and the last curly brace in the statement. I want all that is inside this to be executed as Ruby code rather than to be literally printed to the terminal. So here I'm using the node, which, as we have covered, it is an object that ships with chef.dk. And it is used to grab information about the characteristics of the current machine. We have chosen to print the memory, the total amount of memory that is installed, but because the total amount of memory gets printed with an ugly format, and it is also printed in KB, and we have KB attached to the end of the number, so we want to convert it to a number. So we want just to remove the last 2 characters of the output, which is KB. So we use something called array slicing, because strings are treated in Ruby as arrays. So using slicing, we just printed the first character of the array up till the last character of the array or of the string, but we removed the last 2 characters to give us only the number. Then we converted the whole number to float in order not to lose the decimal places. Then we divided it by 1024 to convert it to megabytes, then again by 1024 to convert it to gigabytes. Then we rounded the output because the output had a large number of decimal places. We needed to round it to the nearest 2 digits. Then, in order to add the label, in order to add the GB letters to the end, we converted the number back to string, and then we are concatenating, or we are adding GB letters to the final output, followed by a new line. Let's save this recipe and let's run it again and see what the output should be. Okay, and as you can see here, it is giving us the correct output. The amount of installed memory on this machine is 0.97 gigabytes. Let's cat specs file, and as you can see here, it is giving us the correct output, 0.97 gigabytes. It is having a new line nicely placed after the output, and it is giving us the correct number rounded to the nearest 2 digits, and it is calculating it in gigabytes, and it is also giving us the label that gives the reader the indication that this number represents the total amount of memory installed in gigabytes rather than in kilobytes or in megabytes. So as mentioned, you don't have to know Ruby to write Chef code, but as you can see here, with simple Ruby methods and syntax, you had a tremendous power over how Chef should behave and how it should format the text written to a file to your own requirements. And that brings us to the end of this lecture and to the end of this section. My name is Ahmed. In the next section, we are going to write more advanced Chef code. We are going to write more advanced recipes, and we're going to see more and more of the power of Chef. So stay tuned. See you next.